Hi guys! In this lesson, I will explain basic electronics in 15 steps. Getting started with basic electronics is easier than you might think. This video will hopefully demystify the basics of electronics so that anyone with an interest in building circuits can hit the ground running. This is a quick overview into practical electronics, and it is not my goal to delve deeply into the science of electrical engineering. If you are interested in learning more about the science of basic electronics, this channel is a good place to start your search. By the end of this video, anyone with an interest to learn basic electronics should be able to read a schematic and build a circuit using standard electronic components. Step 1. Electricity. There are two types of electrical signals, those being alternating current and direct current, or AC and DC. With direct current, electricity flows in one direction between power and ground. In this arrangement, there is always a positive source of voltage and ground source of voltage. You can test this by reading a battery with a multimeter. With alternating current, the direction electricity flows throughout the circuit is constantly reversing. You may even say that it is alternating direction. The rate of reversal is measured in hertz, which is the number of reversals per second. So, when they say that the US power supply is 60 Hz, what they mean is that it is reversing 120 times per second. Speaking of voltage, electricity is typically defined as having a voltage and a current rating. Voltage is obviously rated in volts, and current is rated in amps. For instance, a brand new 9-volt battery would have a voltage of 9 volts and a current of around 500 milliamps. Most basic electronic circuits use DC electricity. As such, all further discussion of electricity will revolve around DC electricity. Step 2. Circuits. A circuit is a complete and closed path through which electric current can flow. In other words, a closed circuit would allow the flow of electricity between power and ground. An open circuit would break the flow of electricity between power and ground. Anything that is part of this closed system and that allows electricity to flow between power and ground is considered to be part of the circuit. Step 3. Series and parallel. There are two different ways in which you can wire things together, called series and parallel. In the circuits on the left, the lamps are connected in series with the battery. In series-connected circuits, the same current flows through all loads. In the circuits on the right, the lamps are connected in parallel with the battery. In parallel circuits, all loads have the same voltage. For example, if the battery is 9 volts, this voltage occurs on all lamps. Step 4. Resistors. As the name implies, resistors add resistance to the circuit and reduces the flow of electrical current. It is represented in a circuit diagram as a pointy squiggle with a value next to it. The different markings on the resistor represent different values of resistance. These values are measured in ohms. Resistors also come with different wattage ratings. For most low-voltage DC circuits, 1/4 watt resistors should be suitable. You read the values from left to right towards the gold band. The first two colors represent the resistor value, the third represents the multiplier, and the fourth represents the tolerance or precision of the component. You can tell the value of each color by looking at a resistor color value chart. Anyhow, a resistor with the markings green, blue, red, and gold will translate as follows. 5 green, 6 blue, times 100 equals 5,600 ohms, or 5.6 kiloohms with a tolerance of plus or minus 5%. Any resistor of over 1,000 ohms is typically shortened using the letter K. For instance, 1,000 would be 1 kiloohm, 3,900 ohms would be translated to 3.9 kiloohms, and 470,000 ohms would become 470 kiloohms. Values of ohms over a million are represented using the letter M. In this case, 1 million ohms would become 1 megohm. Step 5. Capacitors. A capacitor is a component that stores electricity and then discharges it into the circuit when there is a drop in electricity. You can think of it as a water storage tank that releases water when there is a drought to ensure a steady stream. Capacitors are measured in farads. The values that you will typically encounter in most capacitors are measured in picofarad, or PF, nanofarad, or NF, and microfarad, or UF. These are often used interchangeably, and it helps to have a conversion chart at hand. Electrolytic capacitors are typically polarized. This means that one pin needs to be connected to the ground side of the circuit, and the other pin must be connected to power. If it is connected backwards, it won't work correctly. Electrolytic capacitors have the value written on them, typically represented in microfarads. Step 6. Diodes. Diodes are components which are polarized. They only allow electrical current to pass through them in one direction. This is useful in that it can be placed in a circuit to prevent electricity from flowing in the wrong direction. They are represented in a schematic as a line with a triangle pointing at it. The line is the side which is connected to ground, and the bottom of the triangle connects to power. Another thing to keep in mind is that it requires energy to pass through a diode, and this results in a drop of voltage. This is typically a loss of about 0.7 volts. This is important to keep in mind for later when we talk about a special form of diodes called LEDs. Step 7. Transistors. A transistor takes in a small electrical current at its base pin and amplifies it such that a much larger current can pass between its collector and emitter pins. The amount of current that passes between these two pins is proportional to the voltage being applied at the base pin. There are two basic types of transistors, which are NPN and PNP. These transistors have opposite polarity between collector and emitter. NPN transistors allow electricity to pass from the collector pin to the emitter pin. They are represented in a schematic with a line for a base, a diagonal line connecting to the base, and a diagonal arrow pointing away from the base. PNP transistors allow electricity to pass from the emitter pin to the collector pin. They are represented in a schematic with a line for a base, a diagonal line connecting to the base, and a diagonal arrow pointing towards the base. Transistors have their part numbers printed on them, and you can look up their datasheets online to learn about their pin layouts and their specific properties. Be sure to take note of the transistor's voltage and current rating as well. Step 8. Integrated circuits. An integrated circuit is an entire specialized circuit that has been miniaturized and fit onto one small chip, with each pin of the chip connecting to a point within the circuit. These miniaturized circuits typically consist of components such as transistors, resistors, and diodes. For instance, the internal schematic for a 555 timer chip has over 40 components in it. Like transistors, you can learn all about integrated circuits by looking up their datasheets. On the datasheet, you will learn the functionality of each pin. It should also state the voltage and current ratings of both the chip itself and each individual pin. Integrated circuits come in a variety of different shapes and sizes. As a beginner, you will be mainly working with THT chips. These have pins for through-hole mounting. As you get more advanced, you may consider SMD chips, which are surface mount soldered to one side of a circuit board. The round notch on one edge of the IC chip indicates the top of the chip. The pin to the top left of the chip is considered pin 1. From pin 1, you read sequentially down the side until you reach the bottom. Once at the bottom, you move across to the opposite side of the chip and then start reading the numbers up until you reach the top again. Step 9. Potentiometers. Potentiometers are variable resistors. In plain English, they have some sort of knob or slider that you turn or push to change resistance in a circuit. If you have ever used a volume knob on a stereo or a sliding light dimmer, then you have used a potentiometer. Potentiometers are measured in ohms like resistors, but rather than having color bands, they have their value rating written directly on them. Potentiometers have 3 pins to create a voltage divider, which is basically 2 resistors in series. When 2 resistors are put in series, the point between them is a voltage that is a value somewhere between the source value and ground. Step 10. LEDs. LED stands for light-emitting diode. It is basically a special type of diode that lights up when electricity passes through it. Like all diodes, the LED is polarized, and electricity is only intended to pass through in one direction. LEDs will show up in a schematic as a diode symbol with lightning bolts coming off of it, to indicate that it is a glowing diode. There are typically 2 indicators to let you know what direction electricity will pass through an LED. The first indicator that the LED will have is a longer positive lead anode and a shorter ground lead cathode. The other indicator is a flat notch on the side of the LED to indicate the positive anode lead. Like all diodes, LEDs create a voltage drop in the circuit, but typically do not add much resistance. In order to prevent the circuit from shorting, you need to add a resistor in series. You may be tempted to wire LEDs in series, but keep in mind that each consecutive LED will result in a voltage drop until finally there is not enough power left to keep them lit. As such, it is ideal to light up multiple LEDs by wiring them in parallel. However, you need to make certain that all of the LEDs have the same power rating before you do this. Step 11. Switches. A switch is basically a mechanical device that creates a break in a circuit. When you activate the switch, it opens or closes the circuit. This is dependent on the type of switch it is. Normally open switches close the circuit when activated. Normally closed switches open the circuit when activated. Step 12. Batteries. A battery is a container which converts chemical energy into electricity. To oversimplify the matter, you can say that it stores power. By placing batteries in series, you're adding the voltage of each consecutive battery, but the current stays the same. For instance, a AA battery is 1.5 volts. If you put 3 in series, it would add up to 4.5 volts. If you were to add a fourth in series, it would then become 6 volts. By placing batteries in parallel, the voltage remains the same, but the amount of current available doubles. This is done much less frequently than placing batteries in series and is usually only necessary when the circuit requires more current than a single series of batteries can offer. Step 13. Breadboards. Breadboards are special boards for prototyping electronics. They are covered with a grid of holes which are split into electrically continuous rows. In the central part, there are 2 columns of rows that are side by side. This is designed to allow you to be able to insert an integrated circuit into the center. After it is inserted, each pin of the integrated circuit will have a row of electrically continuous holes connected to it. In this way, you can quickly build a circuit without having to do any soldering or twisting wires together. Simply connect the parts that are wired together into one of the electrically continuous rows. On each edge of the breadboard, there typically runs 2 continuous bus lines. One is intended as a power bus, and the other is intended as a ground bus. By plugging power and ground respectively into each of these, you can easily access them from anywhere on the breadboard. In order to connect things together using a breadboard, you either need to use a component or a wire. The most suitable for these wires are jumper cables. Step 14. Your first circuit. If you look at the schematic, you will see that the 330 ohm resistor, LED, and switch are all connected in series with a 9-volt battery. When you build the circuit, you will be able to turn the LED on and off with the switch. You can look up the color code for a 330 ohm resistor using the graphical resistance calculator. Also, remember that the LED needs to be plugged in the right way. If you decide to use the switch, open and close it to see what happens when you make and break the circuit. Step 15. You're on your own. Okay, you're not exactly on your own. You'll be able to access many basic electrical and electronic information you need from the videos on our channel. If you have any additional advice about basic electronics for beginners, please share it in the comments below. I hope it is useful for you and you like it. Hope to see you in our next lesson. Thank you and goodbye.